Hello, thanks for joining me. We're going to talk about multiplying decimals and finding the circumference of a circle. Remember that circumference is a fancy word that means the distance around the circle. So if we could put our tape measure, wrap it around the circle, how long would that line be? And we have a formula for this. And in fact, there's two versions of the formula. Circumference is either this number pi times the diameter of the circle. The diameter of the circle is the distance from one side of the circle to the other, going through the middle. So this green circle shows the diameter. Or we could use the formula 2 times pi times the radius. The radius is the distance from the center of the circle to any point on the circle. The purple circle shows the radius for that particular circle. So to do the purple circle, we'll do that first. We're going to use the formula circumference equals 2 times pi times the radius. And we'll fill in what we know about the circle into that formula. So first 2 is equal to 2. That's not hard. Pi, we're told to use 3.14 for pi. So 3.14. This is an approximation of the number pi, which is a number that in decimal form goes on forever. And then the radius is 5.8. Now, the reason we're doing circumference is not because we care so much about knowing how to do the circumference. It's good facts. It's good things to know how to do. But the main reason we're talking about it now is so that you get lots of practice multiplying decimal numbers together. So our main focus here is going to be demonstrating how to multiply decimal numbers together. And we'll start with the 2 times 3.14. So when I'm doing this, there's no really great way to do this in a line here, so I'm going to take that 2 times 3.14, write it off to the side. I'm going to write 3.14. I put the longer number on top, and then 2 underneath it. Put in the times sign, little bar there, that means equals. We're going to write the answer below. And then we go through the process of long multiplication. We're going to take that 2 and multiply it by each place in the 3.14, starting with the lowest place value. So 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. And then, I'm going to make a big deal about this, we're going to count the number of decimal places in both numbers. And turns out there's 2 places after the decimal in 3.14. There's no places after the decimal in the number 2. We don't have any digits after the decimal point. So we only have 2 decimal places, so we count 2 decimal places in our answer, and we put a decimal point there. Okay, so what we have now discovered is that 2 times 3.14 is 6.28. So I'll write that down. 6.28 is the answer to 2 times 3.14, and now we need to do the times 5.8. That's a separate problem. It's always a good idea to do a kind of a logic test. Let you in on a little secret. I started this recording and I was doing the problem and I was doing it wrong, and I had the wrong answer. But then I did a little logic test. So I said to myself, okay, well, 2 times 3.14 is a little bit hard to do, but 2 times 3 is easy. 2 times 3 is 6. Is my answer close to 6, or is it a little bit more than 6, as I would expect here? And it is. So that's the check to see that I'm doing it right. You always want to check your logic here. Let's do that ahead of time with our second step. So we're going to do 6 times 6.28 times 5.8, but I'm just going to do a little bit of estimating here. I'm going to say, well, 6.28 is pretty close to 6, a little bit more than 6, and 5.8 is a little bit less than 6. What's 6 times 6? 6 times 6 is 36. So I think my answer should be around or about 36. Now, that's a bad idea to say, well, that's the answer, but it is a good idea to have in my mind what I think the answer is going to be close to. And now I'll go through the steps of multiplying 6.28 times 5.8. Again, long multiplication. This one's a little bit better example because we have big numbers, we have lots of decimals in both numbers, and there's more than one digit in the bottom number, so we can show how to do all the steps of multiplication here. First step, we take the first digit, the smallest place in the bottom number, multiply by each of the numbers in the top number. So 8 times 8 is 64. Bring down the 4, carry the 6 to the next place. 8 times 2 is 16, and then we add the 6. 6 plus 16 is 22. Bring down the 2 from the ones place and carry the 2 in the tens place. 6 times 8 is 48. And plus the 2 is 50. We're out of places to carry, so we just put the 5 at the beginning, so 5, 0, 2, 4. Now, we're going to multiply by we're going to do the same process with the 5. We multiply everything by the 8 it's actually the tens place. Now we're going to multiply by the 5 in the ones place, but because it's one place bigger, we need to put a 0 down here as a placeholder. Sometimes some teachers will say put an X there, like just a marker to hold that spot, but I'm going to put a 0 to make it a little less confusing. And now I'm going to multiply everything by 5, but all my answers are going to be shifted over. 5 times 8 is 40. Bring down the 0, carry the 4. 5 times 2 is 10, plus the 4 is 14. Carry the 1. 5 times 6 is 30, plus the 1 is 31. And you can see it's really important to get all your place values like really lined up carefully. If your number tends to be, if you tend to write your numbers sloppily, you're going to crunch together, you squish them together too much, things can get out of line. And it's really important that you have everything lined up very clearly so you can add these together. Now we'll add the two lines together. 4 plus 0 is 4. 2 plus 0 is 2. 0 plus 4 is 4. 5 plus 1 is 6. 3, nothing to add to that. It's just 3. Then finally, we're going to go through and answer the question, how many decimal place values are there? So there's 1, 2 spaces after the decimal point in 6.28. There's only 1 space after the decimal in 5.8. So that's a total of 3 decimal places. So we count 1, 2, 3 spaces in, and then we put our decimal point right there. And the answer is 36.424. 36.424 is slightly bigger than our expected answer of 36. So that doesn't mean we're wrong. It means that we think we're probably on the right track. It doesn't mean we didn't make a mistake here, but it means that we probably didn't make a major mistake. We didn't get the decimal point off by 10 or something like that. So it's always good to check your answers using a little bit of a logical thinking, logical reasoning. If you have mental math, it's easy to do approximately 6 times 6 is 36 in your head just to check to see if that answer makes sense. Okay, that's the first example. Let's go to the second example. We're going to find the circumference. And we should write our answer. Let's do this. Write our answer in words. This is a word problem. What is the circumference of the circle? The circumference is 36.424 centimeters. Now, if we want a very precise answer, that's very precise. If we want to, with a decimal number, we can estimate that. We can say approximately 36.4, almost 36.5 centimeters. So we can be as precise or imprecise as we want to be, but the decimals give us that freedom to do that. Okay, now let's move on to the next one. Again, finding the circumference, we're going to use the formula that includes the diameter because we have the diameter in the second circle instead of the radius. So pi is still 3.14. The diameter is 23.7. This time we only have one multiplication to do, but I'm still going to do it off to the side. I'm going to put the longer number on top, 3.14, and the shorter number on the bottom, 3.7. Okay, actually they're the same length, right? They're both 3 digits long. So it doesn't matter which one I put where, because all of the digits in the top line are going to get multiplied by all of the digits in the bottom line. So this does not matter at all which one I choose. Give myself a little more space. This time we're going to have 3 lines. 7 times 4 is 28. Bring down the 8, carry the 2. 7 times 1 is 7, plus 2 is 9. Nothing to carry. 7 times 3 is 21. Now I'll put a placeholder for the smallest place because we're going over to the 3. Now 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. And 3 times 3 is 9. It's perfectly fine that this number didn't end up being longer than the other number. That's fine. Now we're going to the third place, the 2 and 3.7. So we're gonna put zeros, placeholders in the first 2 places. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Now I was very careful to make sure all my numbers line up with each other in order. Now I can do my addition. 8 plus 0 plus 0 is 8. 9 plus 2 plus 0 is 11. Carry the 1. 1 plus 1 is 2, plus 4 is 6, plus 8 is 14. Carry the 1. 2 plus 9 plus 2 plus 1 is 14. Carry the 1. 6 plus 1 is 7. Now we need to ask the question, how many places do we have here? So 3.14, 1 and 4, after the decimal, that's 2. 23.7, the 7 is after the decimal, that's the third place, so we can count 1, 2, 3 places, and put it in our decimal. So we have 74.418 inches. Now, can we check this answer? Well, let's check it. 3.14 is approximately 3. 23.7 is about 24. The 3 times 24, well, 3 times 25 is 75. Right? 3/4 is 75. So 3 times 24 is 72, I think. And notice that I rounded the 23.7 up a bit, but the 3.14 rounded down a bit. So I'm in the neighborhood. I'm in the neighborhood of 74.4, so I'm relatively confident that I did this right. Again, it's possible that I made a small math mistake, but I probably didn't make a large math mistake because I have my decimals. It's in the right area. Okay, so this check is not foolproof, but it is good, a good thing to do. Okay, let's do a couple of trick questions here, and then one last one, and then we'll be done. So listen fast. I want to do this problem here. Negative 4.72 times 1,000, and this is a really cool trick when you're multiplying by multiples of 10. So negative 4.72 multiplied by 1,000, all we have to do to multiply by a multiple of 10 is you just count the number of zeros. If it starts with a 1 and then a bunch of zeros, you just count the number of zeros and move the decimal over that many spaces. And think about this, negative 4.72, I mean, ignore the negative for a minute, but just think about 4.72 is multiplied by 1,000. It's going to get bigger, 1,000 times bigger. So we're going to move the decimal over so this gets bigger, and we're going to move it over 3 spaces. Now, I actually don't have 3 spaces to move it over, so I'm going to have to put a 0 in here, kind of as a placeholder. It's after the decimal point, so it's okay. And then I can put my decimal there, moved it over 3 spaces, and that's my answer, and that's it. So this is really, really, really simple. So negative 4720. I count over 3 spaces and put a comma, so it's negative 4,720, and that's how that works. So multiplying by multiples of 10, so 10, 100, 1,000, 10,000, 100,000, 10 million, you just move the decimal over however many zeros there are after the 1. Now, the same is true if you multiply by 1, right? If you multiply something by 1, you just move it over 0 spaces. The decimal point gets moved over 0 spaces because multiplied by 1 doesn't change the number at all. But what if you multiply by 0.1? And that is the question. If you multiply by 10, the decimal point gets moved over 1 space. If you multiply by 0.1, the decimal point gets moved over 1 space the other direction. So if we multiply by 0.01, it's going to be 2 spaces. And 0.001 would be 3 spaces. Now, why is it 1, 2, and 3 spaces? It doesn't seem to be following the same rule as the multiply by 10s, where you moved it over as many spaces as there were zeros. Here, we're moving it over as many spaces as there are decimal places. Again, it has to be 1 with a bunch of zeros. So there's 1. The 1 is 1 space after the decimal, 2 spaces for 0.01, 3 spaces for 0.001. Okay, so that's the rule, and we'll apply that rule here on the first question. So we're multiplying by 0.01, so we're going to move the decimal over 2 spaces to the left. We'll make it smaller. Multiplying by a really small decimal number, that means I'm making the answer smaller. So negative 4.72, we're going to move the decimal over to the left 2 spaces. Now, again, nothing there, so we're going to put in a little marker, and now we can rewrite our answer. Remember that the rules of integers still apply. A negative times a negative is a positive, so the answer is going to be positive. And then when I multiply by 0.01, move the decimal place over 2 spaces, and that gave me, I'm going to put a little 0 as a placeholder, 0. Then here's the answer, 0.472. So the decimal place got moved over 2 spaces. Notice there was not really 2 spaces to move it over, so I had to put in a placeholder 0. Plus I have that placeholder 0 in front of the decimal point just to keep it so that it's not confusing. If I just written 0.0472, there's a possibility that decimal point could drop off somehow or be ignored or missed. So when you have a number that starts with a decimal point, we like to put a 0 out front to kind of hold it in place and make sure everything's okay. All right, well, this is going long, but if you would like to watch one more example of long multiplication, we'll do that here. This is a good example because we have a number less than 0 that we're multiplying by. So we're going to put the longer number on top, 49.05. The shorter number on the bottom, 0.047. Now you may be saying to yourself, well, that's not shorter, but it technically is, because we're not going to have to multiply by these zeros. You have to multiply by a zero if it's part of the number, but if it's just a placeholder zero, we don't have to multiply by that. So we're only going to multiply by two digits, the 4 and the 7, and we'll start with the 7. It's the smallest place value. 7 times 5 is 35. 7 times 0 is 0, plus 3 is 3. 7 times 9 is 63. Carry the 6. 7 times 4 is 28, plus 6 is 34. Okay, bring down a 0 placeholder, move to the next place, which is the 4. 4 times 5 is 20. Carry the 2. 4 times 0 is 0, plus 2 is 2. 4 times 9 is 36. Bring down the 6. Carry the 3. 4 times 4 is 16, plus the 3 is 19. Now, again, I could multiply everything by this third place to here, the 0, and then the placeholder 0 at the front, and I'd have two more rows of zeros here. But, of course, 0 times anything is 0, and then 0 plus anything is just that thing, so I don't have to go through that process. Okay, add them all up. 5 plus 0 is 5. 3 plus 0 is 3. 3 plus 2 is 5. 4 plus 6 is 10. Carry the 1. 1 plus 3 plus 9 is 13. Carry the 1. 1 plus 1 is 2. And then I count my decimal places. Last step. 2 on the first number. 1, 2, 3 on the second number. So the total of 5. 1, 2, 3, 4, 5. We put our decimal point between the 2 and the 3. So the answer is 2.30535. Okay, there it is. Could we have predicted this? Well, this is not as easy. We multiplied by a little bit more than almost 0.05, let's say almost 0.05. Well, 0.5 would be 1/2, so this is half of a half. Or not half of a half, I'm sorry, this is a tenth of a half. So we're dividing it in half, but then we're also dividing it by 10. So half of 49 is 28, and divided by 10 is 2.8. That's pretty good. I don't know that there is a good way to think about approximating this, except that if you're multiplying 49 by a really, really small fraction, it's going to get much smaller. So this is going to get really, really small, and that's what's going on here. Okay. That's all I've got for you. Thanks for watching, and have a great time doing long multiplication.